Let's talk a bit about exponential and logarithmic notations. Exponential and logarithmic notations drive people nuts. The thing you have to keep in mind is that all you're doing is presenting a set of information in two different ways. You're presenting the relationship between a bunch of numbers in whichever form happens to be most convenient. So I'm going to draw an expression that has three components to it. Let's see. 3 squared is what? Hey, it's 9. I know that. Even on a cloudy, rainy day where I just want to be in bed. Note that there are three positions here, three numbers that are in the mix. This number is called the base. It's the number that's being raised to an exponent. And hey, that number is called the exponent. It's the exponent on the base. And then this number here, that's the result, right? If we take a base of 3, raise it to an exponent of 2, we get a result of 9. There is a partner arrangement of the same information which tells exactly the same story, and this is called logarithmic notation. The counterpart to this expression in logarithmic form is this. Notice that the same three numbers are in the expression, 3, 2, and 9. They're just rearranged a little bit differently, but they tell the same relationship. Here's a base, here's an exponent, and here's a result. This version of the information emphasizes the result. Hey, if you start with a base and you throw an exponent on it, what result did you get? Down here, we emphasize the exponent that made something happen. So here we see log base 3 of 9, the logarithm base 3 of 9. All we're doing is saying, hey, if you had a base of 3 and you got a result of 9, what exponent did you use to make that happen? Okay, you're very much used to using this particular arrangement to display that information, but this particular arrangement is useful, particularly in some physical sciences where knowing an exponent is just as important as knowing the actual result. For example, when you're measuring things by decibels on a Richter scale or on the pH scale, all of those measurements are numbers that derive from the exponent of a relationship, not necessarily just the result. And so being able to dig out an exponent is really good. If we practice this quickly, all right, here's an easy one, right? 5 cubed. So, hey, there's a base, hey, there's an exponent. What result do we get? Well, 5 squared is 25, 5 cubed is 25 times 5, which is 125. I'm going to ask a question now in logarithmic form. Oh, that looks terrible because it's got a fraction. But remember what the structure is here. All this is doing is saying, hey, if you started with a base of 4 and you put an exponent on it that returned 1 over 16, what was that exponent? Well, 4 squared would be 16. Because there's a reciprocal action, that means that we had an exponent of negative 2. It's the same information written both ways, as exponential form and as logarithmic form. Over here, we could present this information in logarithmic form by saying, hey, we had a base of 5, and we got a result of 125. And what was the exponent we used? Oh, it's right there. It was 3. Okay, so when you're dealing with exponents and logarithms, it's the same relationship between the three numbers. You got a base, you got an exponent, you got a result. The only difference is, are you emphasizing the result, or are you trying to emphasize the exponent that you used to get a result?